Hi, I am Baran, a solo developer building NoCheckout, a co-op horror game coming to Steam. In this devlog, I will walk you through how and why I use FSM, Finite State Machine, to drive player behavior in my game. We will explore how states like movement and interaction are handled under the hood, and how the system stays perfectly in sync across multiple players. Let's dive in. In game development, finite state machines are commonly used to control how characters or NPCs behave in specific states. This allows developers to track clearly defined conditions like walking, jumping, falling, or performing an action. But how does this work in a multiplayer game? If every client determines its own state independently, it can lead to desynchronization. One player might appear to be jumping, while others still see them standing still. That's why it's critical to synchronize finite state machines logic through the central authority, the server. To understand its benefits more clearly, let's look at what FSM synchronization achieves in a multiplayer context. Every player sees the same action at the same time in the same way. FSM states like idle, walking, jumping, or falling are calculated only on the server and sent to the clients. This approach ensures deterministic synchronization across all players, cheating and inconsistent prevention via authoritative server, reliable synchronization of animations, sounds, and effects. In NoCheckout, this system is handled through two major finite state machine components, MovementFSM and ActionFSM. MovementFSM manages basic motion states like walking or jumping, while ActionFSM handles interaction states like placing a barricade or using a medkit. By keeping both of these server authoritative and only sending the results to the clients, we ensure a fair and consistent gameplay experience. Even the simplest movements in-game are managed by the FSM behind the scenes. Whether the player is standing still, walking, jumping, or falling, every transition is governed by the MovementFSM. This FSM is updated every frame based on the ground contact, movement direction, and jump input. For example, when the player leaves the ground, the state switches to falling, and upon landing, it returns to idle or walking. All of these decisions are made exclusively on the server. Clients only receive updated state data, ensuring that every player sees exactly the same movements, no lag, no mismatch. Core states includes idle, walking, jumping, falling, and knockdown. If you are enjoying this breakdown and want to follow the journey from development to the Steam store, consider subscribing to the channel. I will be sharing new features, mechanics, and gameplay right here as they evolve. It is not just movement. Every interaction a player has with the world is also handled through an FSM. Actions like placing a barricade, using a medkit, or opening an electronic door are managed by the ActionFSMs. When a player presses a key to interact, that input is sent to the server. The server then determines what the player is trying to interact with. If a valid item is nearby, the system triggers its interact method, which in turn calls apply to broadcast the effect to all clients. That way, interactions like healing or barricade placement happen visually and functionally at the same time for everyone. To manage movement and interaction animations, I use a system called AnimationController. It receives the current FSM states and controls the animation tree accordingly. The best part? Movement and action states are processed independently but simultaneously. A player can walk and perform a barricade animation at the same time, creating a much more fluid and realistic experience. AnimationController synchronizes movement state and action state across separate blend channels. Each controls animation transitions on its own, while updating the animation tree in real time. This parametric setup not only reduces the system load, but also allows complex animation combinations to run smoothly and reliably. In a multiplayer game, that kind of responsiveness really makes a difference. The FSM system now forms the backbone of the NoCheckout. My main goal was to make the players feel like they truly share the same world in this game. For example, when one player places a barricade, others should see it happen instantly. Or if someone gets knocked down, every teammate should see it right away. That's why I made the FSM server authoritative. So what you see is what everyone sees. As character classes evolve, so will these FSMs, allowing for class-specific movements and abilities managed by the separate states. So far, the results speak for themselves. The system is stable, visually consistent, and responsive across all clients. If you are interested in how this development unfolds and don't want to miss NoCheckout's journey to Steam, make sure to subscribe. I will keep sharing progress right here. See you!